the proceedings that we will be having, no? And hopefully it will be short, so I can upload this one, no? In our YouTube, no? So we talk about, no, again, vectors, and our vectors, no, we realize that we can add them, no? Now the combined effect of 2, 3, or 4 vectors together, it's called as a resultant vector, no? Now we said here now that we can probably deal with 2 vectors, guys, no? And these 2 vectors are 2 forces, no? So an example of a vector is a force, a displacement, a velocity, no? They all have magnitude and direction. Now, commonly, aside from this, now we can draw our vector with a certain arrow at the top, no? So these 2 vectors may be indicated by an arrow, no? Now, how do we get, no, the effect of these 2 vectors? We realize that we can actually divide these, no, vectors into 4 or 3 cases, no? And supposing, no, our vectors are forces, so how do we get the resultant of 2 forces that move, no, in the same direction? So we can actually find this, no, by using, no, 2 processes. One is a graphical method, and the graphical method that we are going to employ is known as tip to tail, no? It's a tip to tail method, and tip to tail method is using your ruler and protractor, no? Do you have your ruler and protractor? Can you flash your ruler and protractor, guys? May I see your ruler and protractor, no? Shaquille, do you have your ruler and protractor? Okay, now we will need that, no, plus maybe your ruler. So how do we combine together these forces that move in the same direction, no? So of course we need our, no, if we are to deal with a graphical method, then we are to use our directional guide, no? So we call this as our directional guide. And we said our directional guide will be indicating, no, the lengths of our vector. So we need as well our scale. Our scale now, we will try to use a scale that is 1 centimeter equals to 10 newtons. Now, do you still remember this one? So for every 1 cm, then we will use 10 newtons, no? And therefore, we are to mark the line that goes east now with 3 markings, no? So assuming that this is 1 centimeter, 2 centimeter, and then this is my 3 centimeter line, no? I'm going to complete that by drawing an arrow, no? The arrow is always anchored at the starting point, no? Then we push it and indicate the direction east, no? So now I call this one as my force or vector number 1 called F1, no? So the length of F1 is 30 newtons, no? Now proceeding, guys, no, and the method that we are to employ is the tip to tail, no, graphical method. At the tip of our first vector F1, meaning, no, sa puntaya, no, at the end of the arrow, no, or the head of our vector, we connect the second vector, no? So vector number 2 called F2 will be connected in front of it. So we will be marking 4 segments. The 4 segments again indicating the 40 newtons, no? And we will now draw our next vector, guys, no? So the next vector, which is still drawn in color blue, will end at the marking, no, called your F2. No? So F2 again is equal to, no, 40 newtons. So our 40 newtons, guys, no? If you notice this, no, it has become long, no? And therefore, kung kwaon naton, if you'll try to get our resultant, no? So where is our resultant? If we are to employ the tip-to-tail method, the resultant will always begin from the starting location, no, called the origin. So from the origin, we draw the line and go all the way to the tip of the last force. So this red line now, or arrow, is now the resultant. No? So the resultant again now started at the, so let's just change the color, no? Because we are confused with our red, no, line. No? So let's just use this yellow color. So the yellow color is our vector. No? So let's say we'll now find, no, the value of our FR. Sorry, no, I think you cannot see that one clearly. No? So our FR now is equal to, no, if you'll try to count the segments, so the value of our resultant now is 1, 2, 3, 4, 5, 6, 7. 7 times 10 is, that makes it now 70 newtons, and its direction is still going east. No? Okay, so we get the value of the resultant by a graphical approach. No? Now, as I've said earlier, there are two methods that we can employ here. No? One is graphical and the other method is analytical. No? Analytical method, now we can think of the analytical method as involving some kind of mathematics, no? Or we can call it as mathematical method. No? Or the mathematical approach. No? Now, the mathematical approach, as you will realize it, no, is much more accurate compared to the graphical method. No? So how do we involve the mathematical method here? No? So if you will try to find, again, no, our method of finding the value of FR will simply be equivalent to the sum of F1 plus F2. No? So kung i-add mo ang F1 and F2 together, so F1 is going right, so it is 30. F2 is also going right, so it's 40. Ang total nila nga duwa is how much?
70.
70, sir.
So it's 70 newtons, no? And it is going east. No? Now, our value for the mathematical method must agree with our graphical method. No? Okay, so graphical involves the tip-to-tail method. No? Intindihan niyo?
Yes.
Who has a question? Okay, now we will go to our case number 2, guys. No? Case number 2 will involve, no? This will be two forces moving in opposite, no? Opposite direction. No? Okay, so what will be our value for this one? No? So let's say our values are, no? F1 is 30 newtons east, and our F2 is 40 newtons, and this time it's going west. No? Again, now if we'll try to use our lead gen again. So here's our line. No? Okay, allow me to transfer the vertical line. No? So here's our vertical line. Now, the first thing that we will draw again now is we will draw this in sequence. Now, whoever is F1, no? We always start with F1, no? The first vector. No? So drawing the first vector, where will we point the first vector? Going right or going left?
Right.
Going right.
Right.
So we mark it, all right? So 1, 2, 3, no? So 3 for 30 newtons. And then we draw our arrow. So this is our first vector F1. So F1 is
13.
30.
30, no?
30.
Now, how about our F2? How do we draw our F2? No? So we will see that F2 will have to be moved, no? Going back, no? So this is our last location of F2. So we count 4, no? Units going left. So starting here, we count 1, 2, 3, and then our 4 will stop here, no? Now again, our method is tip to tail, no? So at the tip of F1, we will start F2. So this will be the tail of F2. So we count 4, no? 1, 2, 3, and that's where your 4 will end, no? Okay, then we draw our arrow. So our arrow will be drawn from here going back, no? Okay, so paano ginakuha ang, how do we get our resultant, guys? The resultant
Deductor.
is, how do we get the resultant?
Subtract, sir.
Yeah, but sa atong graphical method, di na sa natin makita. In our graphical method, it is starting from this end, no? From the origin and going left. So we always start it at the origin and then stop at the tip of the last vector F2, no? So ang aton nga resultant is only this small, no? Ini lang siya, mula din siya kagamay. How long is this line? 1 unit. How many newtons is 1 unit?
10.
10.
10 lang na, no? So ang aton FR value, our FR value this time, no? So our FR value is equal to only 10 newtons. And where's the direction of the 10 newtons now?
West.
It is now going west. So again, the value is only from the origin up to the last tip, no, of the last force. Okay? So any question with our graphical method? So this is a graphical method. What about the analytical method for this one? No? How do we find FR for this one? No? So we will still be adding F1 plus F2, guys. No? Okay, it is vector addition. However, guys, the value of our F1, since it goes right, no, is positive 30. While F2, since it goes left,
Negative 40.
indicated as negative, no? So therefore, our answer will be,
Negative 10.
it will become negative 10. No? Another meaning of negative 10, if you will remove negative, no, sign, negative will mean that it is equals to 10 newtons and the direction is to the left. No?
To the left, west.
So west and the negative sign, no? Pwede nyo lang na siya mahukas ang negative and indicated with west. No? Now, if you're on the vertical line, no, north is positive, south is negative.
Negative.
Do you follow that?